Okay, hello and welcome to another live past paper session. Today's paper is uh, November 24th, 32. This is paper 3. Let's start with the first question. This is about binomial expansion. It says expand this in ascending powers of x up to and including the term in x square. So term number 1. Okay, let me just write down a is 9, b is minus 3x, and n is half. So a power n. Term number 2 is n, a power n minus 1, and b power 1. Term number 3 is n minus 1 over 2 factorial, n minus 2, x power 2. So that's 3. Okay, let's then put things on my calculator to avoid silly mistakes. That gives me minus half x. Gives me minus 1 over 24 x squared. So 3 minus half x minus 1 over 24 x squared. I'm not absolutely sure, so I'm going to check the answer. Yeah, that is fine. The next question says, by sketching a suitable pair of graphs, show that the equation cot 2x sec x has exactly one root in the interval this. Okay, now drawing these graphs. It's a process, you should remember the process. Okay, I just need to go up to 90, so I'm just going to write pi over 2. Okay, a typical graph of cot 2x is the reciprocal of tan 2x. Tan looks like this, but since it's 2x, what I'm going to have to do is I'm also going to have to draw pi over 4 here. Okay, typically the tan graph goes like that, so the cot 2x graph will go like that. Okay, and I think there's an asymptote here that needs to be drawn. Okay, so that is the graph of cot 2x. Sec x will look something like this. Let's draw 1. Okay, sec is the reciprocal of cos. It looks something like this. It hasn't changed. That would be the graph of sec x. Okay, one intersection point means one root. Okay, moving on. This is show that if a sequence of real values given by the iterative formula xn plus 1 equals to half tan inverse of cos xn converges, then it converges to the root in part A. Okay, so I want to show you that this is the same as the earlier equation. And what is the first equation? Cot 2x equals to sec x. So that is what I'm going to try to recreate. Okay, I cross multiply this 2x, tan inverse of cos x, tan 2x equals to cos x. Tan 2x is, if I take a reciprocal on both sides, this becomes 1 over tan 2x and this becomes 1 over cos x. So this becomes cot 2x and this becomes sec x. Okay, so I've shown to you that that's true. Let's check quickly if we've messed something up. Oh, I think we are all fine in terms of the graphs and in terms of the solution as well. Okay, then the third question is from complex numbers. The square roots of 6 minus 8i can be expressed in the Cartesian form this, where x and y are real and exact. By first forming a quadratic equation in x or y, find the square roots of x minus 6. So I want you to find out this. Okay, I definitely can't square roots. I'm going to square both sides. That creates the quadratic that the question is talking about. So x square minus y square plus 2xyi. 6 equals to x square minus y square. Minus 8 equals to 2xy. Minus 8 over 2y equals to x, or 2x equals to y. So y equals to minus 4 over x. Let's put in minus 4 over x here. Okay, 16 over x square. That creates a disguised quadratic equation. Okay. Then I can use my calculator to solve, or I can factorize. This factorizes to 8x square plus 2x square minus 16. X square minus 8 plus 2x square minus 8. X square plus 2 equals to 0. X square minus 8 equals to 0. X square equals to 8 and x square equals to minus 2. This tells me that x and y have to be real numbers. So this can't be true. So discarded. This is true. So x equals to plus minus root of 8, which is plus minus 2 root 2. So when x is 2 root 2, y is minus 4 over 2 root 2. Okay, minus 4 over 2 root 2. It gives me minus root 2. So one of the roots of square roots is this, and when this is 2 root 2, then y is simply root 2. So minus 2 root 2 plus root 2i. Okay, I hope those are the correct answers. Let's check quickly. Yeah, I think those are correct. Okay, moving on to the next question. This is an exponential equation. Okay, you solve these questions using a substitution. So u equals to 5 power x. So u and u into 25 minus 10. So that's 25 u minus 10. U 10, 24 u equals to 10 over 24. Okay, that's u. So I take an ln on both sides. So x ln 5, ln 10 over 24 is basically 5 over 12. So x equals to ln 5 over 12 divided by ln 5. Minus 0.544. Yep, that is the correct answer. Okay, moving on. Question number 5 is again complex numbers. I just did a complex number, it's again there, and this one is about Argand diagrams. This is pretty unusual in terms of the structure that this paper has. I see a linear log question. I've already seen an exponential question. So small questions with a lot of variety. Okay, find the exact value of argument of u. Okay, so what I see is this complex number in the form cos 1 over 7 pi plus I sine 1 over 7 pi. Now, if you remember the rules for modulus and argument, so if I see this complex number, it has a mod of 1 and it has an argument of pi over 7 right now. Okay. The rule for z power n was that this would have n times the argument of z. So n times theta. So the numerator will have an argument that is just the numerator. The numerator will have the argument 4 times pi over 7. Then the denominator is a little different because of the negative sign. Okay, let me check about the negative sign. That's what's bothering me right now. It is minus pi over 7. This would have an argument of minus pi over 7. Okay, because of this negative. You see, the real part is positive and only the imaginary part has gone down negative. So instead of having this theta, I have this theta, and this theta should be minus pi over 7. Okay, when you have numerator and denominator like that, so if z1 and z2 are getting divided, then the argument of the complex number is basically argument of z1 minus argument of z2. Okay, this is basically, oh, okay, I can explain this to you by the conjugate. The conjugate always has the argument that's just negative of the original argument. Okay, so z1 minus z2, so this is going to be 4 pi over 7 minus pi over 7, and that gives me 5 pi over 7. Okay, since this question is about exact values, I can't do it in any other way. I can't evaluate decimals and all those things. This is covered in the topic rules for modulus and argument. Okay, the complex numbers u and u star are plotted on an Argand diagram. I'll describe the single transformation that maps u into u star and state the exact value of argument of u star. Okay, so I just told you that the conjugate is basically a reflection in the line. Conjugate is basically a reflection in the real axis. Argument of u star, if I remember this correctly, is minus 5 pi over 7, I think. Yeah, okay. So that's the relationship between the complex numbers. Question number 6. The variables x and y satisfy the equation this, where a and b are constants. The graphs of L and y against x is a straight line passing through the point this and this as shown in the diagram. Find the values of a and b, giving each value correct to one significant figure. So let's put in ln on both sides. Ln a y equals to ln b power x. So x ln b and ln a plus ln y. So ln y remains here because that has to be an axis. Ln b minus ln a. So according to this, ln b is my gradient. So I am going to calculate the gradient using the points that are given. I'm going to say that 8.27 minus 2.24 over 3.40 minus 0.50 should be the same as ln b. And b should be then e power whatever this number is. Let me just calculate that number for you. 8.27 minus 2.24. 3.4 minus 0.5. 2.079, and then I'm going to go e power that. Giving me 7.9989. Correct to, giving each value correct to one significant figure. So 8.0, I think. Yeah, 8.0. And for LNA, what I'm going to do is I'm going to pick up points and put them here. 2.24 is the value of ln y. X is 0.5. I just found ln b. And I'm going to find ln a accordingly. 0.5 ln 8 minus 2.24. So ln a equals to minus 1.200. E power answer gives me a as 0.3. Okay, that was also the correct answer. Moving on, we are on to question number 7 now. How many questions are there in this paper? 7, 8, 9, 10, 11, 11, yeah. Okay, so we're quickly on to question number 7. This is show that this can be expressed as this. So what I need to get rid of is the double angle here. So it's going to be 2 tan x over 1 minus tan square x. Okay, so tan cube x plus 4 tan x 1 minus tan square x minus tan x equals to 0. Let's take an LCM. So tan cube x gets multiplied with 1 minus tan square x plus 4 tan x minus tan x multiplied by 1 minus tan square x. So tan cube x minus tan power 5x plus 4 tan x minus tan x plus tan cube x. See, something's being added, subtracted, so 2 tan cube x minus tan power 5x plus 3 tan x equals to 0. I see tan x is common to all of them, so tan x, that gives me 2 tan x, 2 tan square x minus tan power 4x plus 3 equals to 0. Okay, this tells you that tan x is not equals to 0, so only this can be equals to 0. I would have normally said tan either this equals to 0, so not possible. So therefore this is equals to 0. Bring it to one side to proof. Minus 3. Okay, moving on. This is a continuation. Just grab some water. So this is the same as the previous one, so it's going to boil down to tan power 4 theta minus 2 tan square 2 theta, sorry, 2 theta minus 2 tan square 2 theta and minus 3, if I'm correct. Okay, so instead of solving this, I'm going to solve that. This is a disguised quadratic equation. So again, u square minus 2u minus 3 equals to 0. So u is either equals to 3 or u equals to minus 1. That's the value of tan square 2 theta. And tan square 2 theta, that one is not possible. This one is, so I have two solutions to tan 2 theta equals to plus root 3 and tan 2 theta equals to minus root 3. My range is from 0 to pi. I need to kick my calculator in radians. Okay, so A and T and S and C. Okay, 60. So the basic angle is pi over 3. So quadrant 1, 2 theta equals to pi over 3. Quadrant 3, 2 theta equals to pi plus pi over 3. Quadrant 4, 2 theta equals to pi minus pi over 3, and quadrant 4 equals to, okay, so the first theta that I'm getting is pi over 6. Quadrant 2 gives me pi minus pi over 3 is 2 pi over 3. 2 pi over 3 divided by 2 is just pi over 3. And then this is 4 pi over 3, so that gives me 2 pi over 3. And quadrant 4 gives me 6 pi minus pi is 5 pi, 5 pi over 6. Okay, I hope those are the correct answers. Question 7. Yeah, all of those are correct. Next is parametric equations. The first part is show that. Let's try to differentiate and show dx over dt is 2 tan 2t power 1 into sec square 2t, and dy over dt is the differential of cos is minus sine 2t into 2. Okay, and this is also into 2. That's what I've forgotten. And dy by dx is then dy by dt divided by dx by dt. Okay, let's cancel that first. So I have the minus half that I'm looking for. I need to change everything to cos, and I want to keep 2t. Oh, that's unusual. Okay, sine 2t over cos 2t into 1 over cos square 2t. So minus half sine 2t divided by sine 2t or multiplied by cos cube 2t. So had you put in double angles, you would have messed up. So that's the correct way of doing it. Okay, that's proven. Find the equation of the normal to the curve at the point where t equals to pi over 8, giving an answer in the form y equals to mx plus c. So that's an easy question. Paper is easy. At t equals to pi over 8. Because pi over 4 cubed, so into minus 0.5 minus root 2 over 8. Okay, so y minus y1 mx minus x1. I don't think I have y1 and x1, so x was basically tan square 2t, so tan 2 pi over 8 tan square. And pi over 4 is 1, so that gives me was 1. And y is cos 2t, so cos 2 pi over 8, so root 2 over 2. Okay, so y equals to minus root 2 over 8x plus root 2 over 8 plus root 2 over 2. Okay, let's check if that is the correct answer. Oh, acha, negative inverse, sorry, equation of normal. This is gradient of tangent. gradient of normal eight over root 2. Thank you, Ali. 4 root 2. Seven root 2 over 2. Yep, that is the correct answer. Question 9, vectors. This says with respect to the origin O, the points A, B, C have position vectors this. The point D is such that ABCD is a trapezium with DC is equals to 3 times AB. Find the position vector of D. Okay. DC is 3 times AB. I think that's a simple question. That's OC minus OD. That's how you break down vectors. And 3 OB minus OA. What's OB minus OA? I can do that directly. That's 0 minus 2. So that gives me minus 2. 4 minus 1. That gives me 3. And 1 minus minus 3. That gives me 4. And what's OC minus 3 minus 2 and 2. So minus 3 minus 2 and 2. Minus, that comes out as minus 6, 9 and 12. OD. Okay, can you hear me now? Okay, yeah, I'm audible now. Okay, so that's the equation of AC. I've used the directional vector of AC or एक का coordinate मैंने use किया है. Then the other equation that I have to form is equation of BD. So I'll have to calculate the vector BD, which is OD minus OB. I did calculate OD and I have OB, so 3 minus 0 is 3. Minus 11 minus 4 is minus 15. And minus 10 minus 1 is minus 11. So R equals to A 2041 plus lambda times, let's call that mu times 3 minus 15 minus 11. Okay, intersection point. To 1 minus 3 plus lambda times minus 5 minus 3 and 5 and 041. Okay, so 2 minus 5 lambda equals to 3 mu. 1 minus 3 lambda equals to 4 minus 15 mu. And minus 3 plus 5 lambda equals to 1 minus 11 mu. Okay, that's a tough simultaneous, I think. 2 minus 5 lambda over 3 equals to mu. 1 minus 3 lambda, 4 minus 15, 2 minus 5 lambda over 3. I'm solving simultaneously. One-fourth, that sounds like a reasonable answer. Mu is also equals to 1/4. Let's see if it satisfies the third equation that I have. Minus 7 over 4 and minus 7 over 4. Yeah. So intersection point is then going to be one of the equations. So 2, 1 minus 3 plus 1/4 times minus 5 minus 3 and 5. So 2 minus 5 over 4 gives me 3 over 4. 1 minus 3 over 4 gives me 1 over 4. Minus 3 plus 5 over 4 minus 7 over 4. Okay, let's check. 3 over 4, 1 over 4 minus 7 and 4. Yeah, that is the correct answer. Okay, using a scalar product, calculate angle ABC. It's going to be cos theta BA dot BC over BA and BC. Okay, BA is OA minus OB. Okay, I'll have to go back and see what OA and OB were. Oh, so 2 minus 0, 2 minus 3 and minus 4. 2 minus 3 and minus 4. Yes, it's absolutely fine to leave it in column vector form unless the question says okay, you have to find it in a particular format. You see the marking scheme should say except, it says except coordinates or equivalent, whichever way you want. Okay. I personally don't like Cartesian coordinates, so I avoid the IJK form. Okay, BC is OC minus OB, so minus 3, minus 6, and 1. Minus 3, minus 6, and 1. Okay, that's OC minus OB. Okay, so cos theta, BA, BC, dot product, right? Dot product. BA is root of 2 square minus 3 square and minus 4 square. And minus 3 square minus 6 square and minus 1 square and 1 square. Minus 6 plus 18 minus 4. 4 plus 9 plus 16. 9 plus 36 plus 1. Okay. Putting them up in the other form, 18 minus 10 is 8. Shift cos inverse of 8 over root of 13 and 16 is 29. 36 and 10 is 46. Okay, my calculator is in radians. Let's change that to degrees. It doesn't say otherwise, so I can do radians as well if you want. I am getting theta as 77.3. Yeah, 77.3. Okay. Question number 10, it says a balloon is in the shape of a sphere, has volume V and radius R. Air is pumped into the balloon at a constant rate of 40 pi. When t equals to 0, R equals to 0. At the same time, air begins to flow out. The balloon remains a sphere at all times so that R and T satisfied. So it's the volume that's changing first, 40 pi minus 0.8 pi R. But I don't want to prove to you volume. I want to prove to you that dr over dt, the volume of a sphere, is given as 4 over 3 pi r cube. That should be there in the formula sheet as well. You differentiate that to find dv over dr, and then you convert dv over dr into a rate of change. So dv over dt divided by dr over dt. So 40 pi minus 0.8 pi r, 4 pi r, 4 pi r square, and that's dr over dt here. You shuffle things around. 40 pi minus 0.8 pi r, 4 pi r square. I see pi is common to all of them, so let's get rid of that. Then there needs to be some simplification in terms of the numbers that are here. So let's first change this to 0.8 is basically 4 over 5. Okay. So in the numerator, that gives me 5 into 40 is 200 minus 4r. And that 5 then gets multiplied with this. So I get 400 minus 4r over 20r square. I see 4 is common, so 4 into 200. 50 minus r square over 20r square. I've done a lot of calculations there. You could avoid a lot of them by just simplifying the numbers. Okay, but that's what you had to do in this question. Find the quotient and remainder when 5r squared is divided by 50 minus r. Okay, so 5r squared, I'm going to write minus r plus 50 because you should have them in order. So minus r multiplied by 5r, minus 5r will give me my plus 5r square and give me a complementary term that's minus 250r. I change the signs, get rid of that, and I'm left with 250r. Then I use minus r, again minus 250. So that gives me plus 250 r and minus 1250. Change the signs again, 1250. So the quotient is minus 5r minus 250 and the remainder is 1250. You can't do this question without long division. Just be aware of that. Yeah, I could have taken 0.8 common. That would have solved a lot of problems. I didn't do that earlier. I realized that later. Okay. Have I messed up this numbers? Yeah. Okay, solve the differential equation in part A, obtaining an expression for t in terms of r. So I had dr over dt. That looks like this, 50 minus r over 5r squared. I have to move that here. Dr. Okay, since they've asked you to do long division in this, you've already done this. So you have a quotient, so minus 5r minus 250 plus the remainder over the divisor. Typically, when you write a mixed number, what do you write? You write the quotient and then you write the remainder over the divisor. Okay, in algebra, when you're doing that, you just write a plus in the middle. So 12,500 dr 1 dt. Now you integrate both sides. So minus 5r square minus 250r plus 12,500 ln 50 minus r divided by minus 1 equals to t plus c. When r is 0, t is 0. ln 50, so c is minus 12,500 ln 50. Okay, obtaining an expression for t in terms of r. So 5 minus 5r square minus 250r minus 12,500 ln 50 minus r equals to t minus 12,500 ln 50. To bring that to this side, this should be minus 5r squared divided by 2. My bad. Okay, I want to check if that is correct. Yep, all of that is correct. And let's find the value of t when the radius of the balloon is 12. So t equals to 12,500 ln 50 minus 512 square over 2 minus 250 r minus 12,500 ln 50 minus 12. I think answer should be 70.5. Yep, that is the correct answer. On to the last question then. What is this question about? Stationary points and then integration by substitution. Surprisingly, there's no integration by parts or partial fractions in this exam. F bar of x. So u equals to this, v equals to this. Dy by dx, u dash v plus v dash u. Okay, e power 2x is common. 2e power 2x is common, so 2e power 2x. So 2 e power 2x minus 3 e power x plus 2. And I've taken all of that common, so plus 2 e power 2x minus 3 e power x. So either this equals to 0 or that's f bar of x if you want to write it like that. That's what I thought कि जिस तरह के डिनोमिनेटर उसमें पार्शियल फ्रैक्शंस बन जाएंगे वो सब्स्टिट्यूशन के बाद बनेंगे. Okay, you use the substitution to get through this. So u equals to e power 2x. So 4u square minus 9u plus 4. So that equation is correct. Okay, what I have done is that this was supposed to be a quotient rule and not a product rule. Let's turn that into a quotient rule. Okay, we'll also change the signs here. I don't know if that's correct. Yeah. And the exact coordinates. So those should be the exact coordinates of x, and I need to calculate y. I can just use, instead of doing this, just verifying if ln 4 over 3 is correct. Yes. Okay, so if e power x is 4 over 3, then e power 2x should be 16 over 9. That's just a square. So 2 times 16 over 9, 16 over 9 minus 3 times 4 over 3 plus 2. Put all of that on the calculator. Minus 16. Okay, yeah, that is the correct answer. Last part, use the substitution e power x and partial fractions. Okay, it says partial fractions here. Find the exact value of this. Okay. That's 2 e power 2x, e power 2x minus 3 e power x plus 2 dx. So u equals to e power x, du over dx will be e power x again. So I can replace dx with du ex. Let's see when that happens. So this becomes 2u square minus 3u plus 2. Looks like an improper fraction, but it does convert into proper fraction. That's du over u. Okay, so that becomes 2u square minus 3u plus 2 du. I will have to do partial fractions here. So 2u over u square minus 3u plus 2 is going to break into, now what are the factors of, you will have to do that manually. Minus 2u minus u plus 2u, u minus 2 minus 1, u minus 2. So u minus 2 and u minus 1. So u minus 2 and u minus 1. So a times u minus 1 plus b times u minus 2. And the other side has 2u. So I use a cover up method, u equals to 1. So 0 plus minus 1. So minus b equals to 2, b equals to minus 2. I don't have another page. And then u equals to 2. Okay, I'm just verifying if my partial fractions are correct. Minus 2 and 4, I think. Yeah. Okay. So minus 2 over u minus 2. No, sorry, 4 over u minus 2 plus minus 2 over u minus 1. So 4 ln u minus 2 minus 2 ln u minus 1. Both of these are divided by 1. What are the limits? The limits were for x, ln3 and ln5. So u is 3 and u is 5, so 3 to 5. 4 ln 5 minus 2 minus 2 ln 4, let's call that 3. Okay, 4 ln 1 minus 2 ln 2. So 4 ln 3 power 4 minus ln 4 square plus ln 2 square. Ln 3 power 4 into 2 square divided by 4 square. 81 over 4. Yep, that is the correct answer. That is the end of this exam. This wasn't a very difficult paper. I just had to be careful about a few things. Otherwise, the paper was generally simple. I will see you in the next live stream with the variant 3.3 for November 24. Thank you for watching.